This chapter is on extracting rotations. Like I said, we're going to use two different methods to extract the rotations and be able to drive a twist bone. With the forearm, we used constraint system. It's very simple, very fast to use. Quite frankly, a great way of doing it. I'm not sure there's a big advantage of using script controllers, other than showing you that you can actually extract a rotation and drive something with it. This can be used in many different areas of a character rig, many different ways, where maybe a constraint isn't practical or isn't going to do what you want. In this case, we want to drive the local x-axis along the twist of this bone. And we're going to use a script controller to do it. We want to extract the rotation difference only on the local axis of this compared to the local axis of this. Now the problem being is the upper arm bone and the clavicle bone aren't aligned at all at this point. So that means that any rotation value we get is going to be some arbitrary value to start with. It could already be rotated by, X amount of degrees. We want to start with 0. Our X value is currently 0, so we want a 0 value to start with. And it's best to work it that way and make sure that we extract something that's starting at 0 and going up and down from there, and we'll get a better idea of what we're doing. To do that, I'm going to use another object. I'm not actually going to extract the rotation from between the upper arm and the clavicle. I'm going to extract from the upper arm to some other object. That other object in this case is going to be a point helper. I'm going to align the point helper up to the upper arm and then link it to the clavicle. This way I know that this object and this object are aligned together in orientation, and when I extract a rotation between these two at the default pose, it will simply be 0. The twist bone is already been linked up to the upper arm bone, so I'm going to go to the motion panel with the twist bone selected. I'm going to go into the rotation X value that we want. I'm going to change the controller to a float script. Now this float script is showing us a value already that the bone has been rotated at along the x-axis. This is an exponent value, so this is about as close to 0 as you're going to get. So 0 would be the same sort of thing. If I set evaluate, you won't see the bone move. I want to leave the 0 in there for now, just so that I can not have errors happen as I'm writing the script and can test parts of the script as I go. We're going to add to this script as we go and change it. But first off, if you want to make a script controller, just a default script controller, interactive on screen when you're moving things, you have to use a depends on statement. The depends on statement basically says that this script controller depends on an object for its values. And in this case, I'm going to say depends on, and I'm going to use this bone and depend on the rotation of this bone basically. So I'm going to take this bone and copy it into my script controller. I use a $sign previous to the name of the bone, because the $sign tells MaxScript that this is an object in the Max file that I'm currently targeting and looking at. It isn't just a variable called bone07, it is an actual object in the scene. It isn't going to matter to our script, but it will when I start showing how other parts of it work. I'm going to also make it depend on the point helper as well for now, to show you a little bit more about how the two interact together. We have to use a bit of math now, a bit of matrix math, to be able to extract the rotation from one to the other. Like I said, you can't just pull a local rotation out of that bone and expect to get something that's going to be useful. It's not. Every object sits in parent space. You need to get the local rotation value, in a sense, what people call local rotation, by extracting it. The way that's done is by multiplying the transform of this object with the inverse of this.